We want to take the first and second partial derivatives of this function f. So one of the first things we're going to need to know is the product rule for differentiating a product. So when f is u times v, then df dx is u dv dx plus v du dx. And although I've written it for normal derivatives, this is equally true for partial derivatives. So first we're going to take the x partial derivative of f, df dx, and in doing this I'm going to treat this term as u and the etx as v. So that's going to be u. So now I want partial derivatives, dv dx plus v du dx. So first we leave u alone, 2xy squared minus 4y, and we differentiate v, which is e to the x, with respect to x, and the derivative of e to the x is just e to the x. Next we take v, which is e to the x, and multiply by du dx. But when I take the partial derivative of u with respect to x, I'm going to treat y as a constant. So the first term, 2xy squared, that's just a constant, 2y squared times x, so I just keep the constant. So du dx is just 2y squared, and now I look at the second term, 4y squared. I'm treating y as a constant in this case, and the derivative of a constant is 0. So I'm finished, except that I'd like to tidy this up a bit for when I come to take second order derivatives. So I'm going to write everything as something times e to the x, which is a common factor. So I keep 2xy squared, I keep minus 4y, and now from the other term I also need 2y squared. So I'm going to carry on with the x derivatives, and now I'll take the second partial derivative with respect to x, d2f dx squared. So that's just d by dx of df dx, which I calculated above. This is df dx, and again it's a product. I'm going to treat the first term as u and the e to the x as v. So again this is going to be u dv dx plus v du dx. So first of all I keep the u, that's going to be 2xy squared minus 4y plus 2y squared, and multiply by dv dx, which is just d by dx of e to the x. That's the same as before. And then v, that's e to the x, times du dx. But when I differentiate with respect to x, I treat y as a constant, which means it's only the first term of u which has a non-zero derivative, because 4y and 2y squared, they're both constants. Derivative of a constant is 0. So it's just the 2xy squared term that I need to take a derivative of, and that I just treat as constant times x, so I just keep the constant, 2y squared. So again, I'm going to take out a factor of e to the x, and then that's going to multiply 2xy squared minus 4y, and now I have two lots of 2y squared, one from u dv dx and one from v du dx, so I now have four lots of y squared. So that's me done for d2f dx squared, but I'm also going to calculate a second cross derivative. So I also need to calculate d2f dy dx. So that's d by dy of df dx. And in this case my job is much simpler, because my v, e to the x, I'm now going to treat that as a constant because I'm differentiating with respect to y. So I don't need to worry about u dv dx, or rather u dv dy, because e to the x has no partial derivative with respect to y. So e to the x I now treat as a constant, and I take the y derivative of my u, 2xy squared minus 4y plus 2y squared. So that's e to the x. And now I just differentiate the second part term by term. So that's 4x, which I'm treating as a constant, times y, minus 4 plus 4y. So that's all the x derivatives. So the next thing I need to do is start looking at the y derivatives. So just to remind you, f two xy squared minus 4y. So now when I take df dy, I don't need to worry about using the product rule, because I'm going to treat the second factor, e to the x, as a constant. E to the x just sits there, and I take the y derivative of the term in brackets. So that's 4xy minus 4. Take the partial derivative of that with respect to y to get a second partial derivative, d2f dy squared. So again, treat e to the x as a constant, differentiate the term in brackets with respect to y, and that just gets me 4x. Now I also need to take the cross derivative, d2f dx dy. So that's d by dx of df dy. And here I do need to use a product rule. So I'm going to take this as u, this is v, and that's going to be u dv dx plus v du dx. So what does that get us? So u e to the x dv dx, that's just 4y, And now v, 4xy minus 4 times du dx, which is just etx. So I take out my common factor of e to the x, and I have 4xy minus 4 plus 4y. So that's d2f dx dy, but that's also equal to what we calculated before, d2f dy dx.